Okay, so I know there's a lot of, just like misconceptions. Well, not really misconceptions. There's just like, a lot of people that are getting into this, and there are a surprising amount of people, even technicians, that don't know how to wire fire alarm systems together. And it's always been a shock to me, like, whether it's a helper or a tech that's, been at the company longer than I have, and they don't know how to trim out a panel or anything like that. So I'm going to kind of discuss the systems that I know. Um, so basically, most fire alarm systems, they have, these days they have SLCs and they've got NACs, and then they might even have a like an annunciator bus, which is what your annunciators connect to. So the that brings me into question of the day. What is the most common data bus that is used in the industry? Put your comment below after the video is over. So, yeah, you will have SLC, you will have your NACs, which are your notification appliance circuits, SLC being signaling line circuit, which is your addressable data bus that basically controls all of your initiating and some of your output devices, like addressable relays and stuff. All the other stuff would be like monitor modules, um, pull stations, smoke detectors, just some of the basic components of a normal system. Um, and then you're also going to have on smaller panels, it's built in, you're going to have something called a DACT, which is short for Digital Alarm Communicating Transmitter. And that alone is not capable of dialing out to the fire department. You actually have to get a cell dialer or cell radio to do that. So you program the phone line numbers into the panel and the account number, and then it sends those through the DACT on the panel to the dialer, and then the dialer is what sends those signals out. So, but also don't think that, disconnecting a dialer will bypass putting it on test, because as soon as you plug it back in, it's going to send all of those signals out. So just don't do it. Please, for the love of God, just put it on test. I promise it's way better. Especially if, you're doing a final and the fire marshal makes you check signals. Believe me, they'll hit you with that when you least expect it. So, yeah, make sure that your dialer is running properly. So, with that, there's a few other things like, there are onboard relays on most panels um, that are able to be programmed. Most of them have a trouble relay that cannot be changed, and then they have two others that are programmable, which are generally used for alarm and supervisory. I know Gamewell E3s, they are set. You cannot change them. But smaller panels like anything Fahrenheit, Silent Night, you can configure all of the onboard relays, minus the trouble relay. I don't think there's any that you can change the trouble relay on. So you're gonna have to excuse my voice. I'm a little sick. Woke up this morning with a really sore throat, and then it kind of went away after I got rid of some phlegm, and then the sore throat's kind of subsided, but now I'm getting really hot nose breath, so I know what that means for me. One of those sicknesses that you only get like twice a year. So you're just gonna have to bear with me. um, so I mean, there's not really a whole lot to most panels. As you get into bigger, more complex systems, you're gonna have bigger, bulkier setups. Like a Gamewell E3, you know, you're gonna have multiple things that you're gonna have to put in there, and it does not come built the way that you need it from the factory. It comes as literally an empty can. You put that can on the wall, and then you have to get a plate for it. And there's different plates. There's INCC, which is for command center, and then INX plates, which is for amplifiers for voice. So if you have a D-size enclosure and you're doing voice all in the same enclosure, you need an INX D plate. So yeah, that gives you 3 slots for normal cards and then 2 slots for amplifiers. And you can stack cards on top of each other. But going between those, most of the time you'll be using ribbon cables, which communicates over the equivalent, Gamewell's equivalent of S-Bus, which would be just like a 2 pair of wires. And when it comes to S-Bus, you know, when you're doing S-Bus runs, you don't have to use the positive and negative on the panel. You can, you know, if you want to avoid having to run a 4 conductor, then like if there's a power supply that's closer to an annunciator that you're putting up, you can just run a 2 conductor from that power supply, set that to aux power, and then that can power your annunciator, and then your S-Bus data, you know, just your A and B can power it, and it will work fine. So you absolutely do not have to use the power on the panel. In fact, I see people use it a lot for like, you know, powering their dialers and stuff. And you know, that's fine. But I just prefer to change one of the NACs to aux power, and then it's no longer supervised. So that's actually a dedicated, you know, circuit. So that's pretty cool. But basically with E3s and evidently with 4100s, you know, you got a bunch of distribution going on. And, you know, once you build the E3, you have to wire all of it together. And most of the time, people use fire alarm wire. You know, it looks good. What can they say? But with 4100s, all that is internal. So like with the PDIs, the power distribution modules, stuff like that, you know, it's all communicated like internally. So like power, you know, you put a card in, it has power. You don't have to run wires to it like you would on an old system like a System 3, which if you've ever seen one of those, wire harnesses for days. Like, I feel like the amount of scrap you could get, the amount of scrap wire you could get from one of those panels would probably be enough to, no, okay, no, not really. But, yeah, that's pretty crazy that, you know, how drastic the differences are in, like, you know, Simplex and Autocall to Gamewell, and even Notifier, which, I don't know too much about Notifier. I know mainly about Gamewell and Autocall and Silent Night. You know, those are just the ones that I'm the most familiar with. But, and then there's power supplies as well, and those are wired a little bit different. The most common one now is the Honeywell PS6 and PS10 series. And basically, with those, they need a dedicated 120 volt circuit. It can be on the same one as the fire panel if it's close enough to make sense. But you don't want to use the main panel as a pass-through. You don't want to have 2 wires on each terminal. That's against code. That's against NEC, actually. NFPA 70. So, and you know, knowing codes is also really, really good when you're trimming out panels, you know. Because if you have a power supply next to a panel, you know, you don't want to run your SLC through that power supply unless you're using a control module to power it, which, you know, might make sense if you're using all the NACs on the panel already. but otherwise it's kind of redundant, especially like, I've seen some where, like, power supply is next to the panel, no NACs on the panel are being used, and control module was used. But for the sake of that, it did make sense because with E3s, it can be really complicated to get control modules to sync with panel NACs, just from my experience. So, yeah, I know, sucks. But yeah, most of the time, people won't really care about that. They won't really care about stuff like that. But it's always good when someone does, because then it motivates you to not only do it right, but you're gonna have a much cleaner looking install. So, like, if you've got a power supply and then an amplifier cabinet, and you're using the power supply to run the speaker wire through to go to the amplifier cabinet, guess what? That's a code violation. You're using panel enclosure as a pass-through, and that's not allowed. So, and it becomes especially painful when it comes to doing retrofits. Whenever you have to replace something, you don't want to cut all those wires. I've seen a situation like that where it was just easier to take the guts out and leave it there, and then maybe just put some terminal strips to clean it up a little bit. But yeah, if you're gonna do power supplies together, you really need to do conduits going up from all of them, not just one. So but yeah, most power supplies, Honeywell wise, they're going to be the same. You're going to have your NACs going out. The old ones, which we call honey badgers, the ones that have 4 NACs, and then they've got a sync input and then an output. They're really complex, and you can only set them to one sync protocol. And then they have a switch number 8, which changes NAC 4 to a door holder circuit. And that's nice and all, but the PS10, and the PS6, they kind of took I guess they took a patent from Potter with their PSN 106, and they made it so that you can do all of these different sync protocols on the same panel. It allows you to do System Sensor, Wheelock, Gentex, Faraday, and AMSICO on the same power supply. The only thing is they have to all be on the same circuits. You can't have Gentex on a Wheelock circuit, even if it's at the end of it. So, yeah. But being able to do that is a really nice thing. So, you really only be able to do that like if it's like a 1 or 2 story building. It's really not ideal because most people are going to want the strobes in the entire building. Like from the street, if it's all glass, they're going to want to be able to see that it's all in sync. So, yeah, but knowing good wire practices, stuff like that, it's really, really good. One day you'll trim out a panel and then you're just like, wow. You don't ever want to do it and, make it look like a trunk slammer did it, at like 4 o'clock on a Friday. Nothing good ever comes of that, and people do not appreciate that, especially service. Because managing that is a lot harder than you think. You don't just unplug everything and try and start from scratch. Because you'd want to know what each wire is, and if you do that, then you're going to lose track pretty quickly, unless you label them. And, labeling your wires is another good thing, whether it's with Sharpie, if you have a label maker, stuff like that. Even colors, like, if you've got different color, like highlighters, You like, or different color Sharpies, like mark the screw terminals. Like maybe you can mark one like blue, mark one green, mark one silver, mark one gold, maybe. Mark your wires the corresponding colors, you know. And not even really the wires, just the jacket that the wires are in, which generally will be red because, red, fire alarm. That's mostly what is seen in the industry as far as fire alarm wiring goes. But I have seen different colors. Like I know standard that Siemens uses, at least Siemens San Antonio branch. They do yellow for NAC, they do purple for speaker, and then black for SLC. I think. I could be totally wrong on that. I know another company they do blue for NAC, red for speaker, and then black for SLC. Actually, I think Siemens. No, I think Siemens does blue for speaker and then black for SLC. Or no, I think it's blue for SLC and then. I don't know, actually. I do not remember. So yeah. But there's definitely a lot that goes into these systems, but knowing how to terminate those connections properly is huge. And it's always nice when you can have a big system trimmed out and your superintendent doesn't have to spend half a day wiring it his way and making it look really nice, which me, I would enjoy doing that. But I kind of like when people know how to do something on their own. It gives me a sense of pride because I've taught a few people some things. I don't like to teach them like the trunk slammer things, like there's the old beanbag on a jet string trick, throwing that over to run a wire. um, there's stuff like that guys are like, oh, you will never find this in a book. And for very good reason. So yeah, don't do that. Fire alarm wire is not supposed to be run just like any way that you can throw it, especially if it's diagonal. Fire alarm wire, by code, by the federal published code, is supposed to be run in a workman-like manner. Means all straight runs, no going diagonal. Any support that is for fire alarm is to be for fire alarm only. So if you're doing like a nurse call, same company is doing nurse call, they can't use those supports for the nurse call wire. And you don't want to, because there are some problems that can arise from doing that. So a lot of different systems, they generate sorry. They can generate impedances, and they can interfere with the signal on your systems. So I know there was one place, a controls guy got onto my foreman, one of my foremen, because he put his fire alarm wire in the same bridle ring as a control wire. He's like, hey, I need you to get that out of there because we'll get impedances on that and it's going to make the system run slower because of that. I was like, okay, I will do that right now. And I did. So yeah, you'll get ridiculous impedances if you have fire alarm wire anywhere near AC voltage. If you have it anywhere near line voltage, you are going to get some of the craziest interference that you've ever seen. It can generate false alarms. It can do all kinds of crazy crap. And that's one of the reasons why it's not allowed to be run in the same conduit as alarm wire. Which I feel like, even if the alarms were powered by 120 volts, it still wouldn't be allowed to be run in the same raceway. Just because There's already lots of redundancies in fire alarm. What's another one gonna hurt? You know? Stuff like that. Oh, excuse that. Oh my gosh. I am not feeling good. I'm sorry. But yeah, and that's why, you know, back in the day, back when addressable systems were still kind of coming around the corner, the SLC was supposed to be run in shielded wire, so they could only be installed in new buildings, just because, you know, that shield keeps out interference, especially if it's grounded or, you know, bonded with the negative terminal. But you really only do that with speakers, and I'll get into that in just a bit. But now shielded is no longer required because it's no longer even, you know, really recommended, because, you know, the efficiency of these has gone up very drastically. So like you could do it in a building with, like, you know, you could use THHN as it is and it would work fine. So yeah, and then, you know, same thing with speakers, and this is a very, very notorious case. If you do not use shielded wire, shielded cable for speakers, and you run it in the same conduit as your SLC, you are going to hear some crazy noises over your speakers constantly. Okay? Thanks to a lot of interference, I know what different SLC protocols sound like. Okay, I know what Velocity sounds like, I know what SK sounds like. I still have yet to hear Apollo, and I still have yet to hear SD and IDP, stuff like that, but yeah, I have to say Velocity sounds the best. I like the way Velocity sounds. But yeah, so I might do a video on that one day, you know, what different SLCs sound like. And if you put a speaker, if you wire a speaker straight to the SLC, you will get that noise, you know, coming straight out of the speaker, and it won't hurt it at all. It won't even throw a trouble onto the SLC. So that's something that you can try at home or at work if you're just bored on the job. But yeah, try not to get in trouble doing it, or you know, try and give someone the wrong idea. You know, they might not like that. So, but yeah, yeah, with speakers, there's definitely potential for some crazy interference, whether it's from AC lines, which thankfully pretty much all AC lines are going to be in a raceway. So, and that raceway is pretty much always going to be grounded. I still have yet to find one that is not grounded, and hopefully I never do. So, yeah, I mean, that's kind of just the basics of alarm systems, you know, how they're wired, stuff like that. You know, your notification appliance circuits, those are, you know, your horns and horn strobes, or in some cases just strobes, where you've got speakers, and then your speaker NACs where applicable, which, yes, a speaker is a notification appliance, and a speaker line, a speaker circuit, is considered a NAC. So, GED. No, I'm kidding. But yeah, and then your SLC, that is your data. That's where all of your initiation devices and some of your output devices will go, at least your addressable output devices. And then annunciators will go on S-Bus or ANN bus, or what is the most common data bus that is used? The most common mod bus that is used, rather. Put it down in the comments. Let me know. And plan to do another one of these videos pretty soon. I really like doing these. So I appreciate y'all watching. And I will talk to y'all real soon. I'm going to get some rest now.